Okay, I'm back, and so I want you to take a close look at those two pictures, the picture on the left and the picture on the right. So without looking at the captions, there should be two things that you should be noticing. Okay, one is that the curves, which are indicating the global ocean currents, are different. So do you notice that? And then number two, you should be noticing that the position of the continents are slightly off. And in particular, do you see that there's a gap between North America and South America? That's very important. So if you've got North America is up here, so here's my artist's rendition of North America. And then down here, this is going to be South America. Pretty good, eh? Well, anyway, what you should notice is there's a gap between North America and South America that is allowing ocean water to go straight through. Whereas, if you look at the picture on the right, you see North America and South America connected, and now that has disrupted the global ocean currents. And when that happens, that tends to cool down the planet. And we think that that's one of the primary things that triggers ice ages, is when the ocean currents are disrupted by the presence of different land masses. So the picture there on the left shows you what did the Earth look like during the Paleogene, which was, roughly 20 million years ago. And you can see that North America was a separate continent from South America. They had not collided yet to form the Isthmus of Panama. You also notice that the global ocean current went right through the Straits of Gibraltar, right through the Mediterranean, and then directly out into the Indian Ocean. So notice that the Red Sea's not there and that the Mediterranean isn't cut off yet. So again, during this time period, you had ocean water that was able to freely circulate around the world. But once the continents came together and started to block that ocean flow, then we think that that might be what triggered the ice ages to start to occur. Okay, another thing that the land can do is it can change the sea level. So if you have an increased rate of sea floor spreading, okay, so what happens at a sea floor spreading center is that you've got material in the asthenosphere, and then it's coming up and it's going to be causing this oceanic plate to move this way, and then this oceanic plate over here to move this way. And then where this material comes up, it's going to harden and make new ocean floor, and then new stuff comes up underneath it and breaks it so that the old ocean floor has to move away, and then it forms new ocean floor in between. So if you have a spreading zone region that has a high rate of material coming up, then this is going to be topographically higher than, let's say, down here. Here's another spreading center that is not so active. And so you notice it doesn't push up the ground as much. Well, the more it pushes up the ground, the water has to go somewhere. So the water, which is on top of this mid-ocean ridge, it gets displaced if this is being pushed up higher. And so what tends to happen is that water will slosh onto the continents. So that you have the continental shelves, which are actually part of the continent. And then when this water sloshes up, it can cover those continental shelves. And sometimes the water will even get into a continent. So when I have my lesson on the history of the Earth, you will notice that on some of the slides that the continents are covered up by water. And so we think that that's a result of an increase in seafloor spreading. Okay, and then finally, let's talk about the biosphere. So we said that the cryosphere could store water in the form of glaciers, and so then that would tend to make the water level lower because it's pulling water out of the oceans. Then when these glaciers melt, that's going to add water to the oceans. And so the more water you have in your oceans, the more evaporation you're going to have, and so you're going to have more weather as a result of that. Then we've also talked about the hydrosphere and the hydrological cycle. We've talked about what's going on in the atmosphere of the Earth, and we've talked about what's going on in the geosphere. So finally, let's talk about the biosphere. So the biosphere is going to be plants and animals. Animals produce carbon dioxide and plants remove it. So plants, through the process of photosynthesis, are going to remove carbon dioxide from the atmosphere. So what's that going to do? It's going to make the planet get cooler. So the more plants you have, the more carbon dioxide will be drawn out of the atmosphere. And remember that carbon dioxide was a greenhouse gas, so without it, then the planet's going to get cooler. On the other hand, let's say that in South America, one of the problems that we're having is deforestation. So as we cut down the rainforests, then that means that the rainforests are not drawing in as much carbon dioxide, and so that means that there's more in the atmosphere, which means that the planet is going to get warmer. So this shows you how the biosphere can interact with the atmosphere and the geosphere, and so all of these things are interconnected with each other, which we call the Earth system. Okay, now we're going to shift gears and we're going to talk about what are landforms.